Hello all. So in today's class we will look at the case 1 where the roots of the characteristic equation are real and distinct. So we will look at what is the form of the general solution when you have the roots to be real and distinct. So this is a theorem which gives what is the form of the general solution. So if the roots lambda 1 and lambda 2 of the characteristic equation associated with the system are real and distinct, then the system will have two non-trivial linearly independent solutions of the form. So if the roots are real and distinct, രണ്ട് linearly independent solutions വേണം നമുക്ക്. So that will be x equal to a1 e raised to lambda 1 t and y equal to b1 e raised to lambda 1 t. That is the first pair of solution where a1 and b1 are some fixed constants. ഇനി അതുപോലെ സെക്കൻഡ് പെയർ ഓഫ് സൊല്യൂഷൻസ് എന്ന് പറയുന്നത് that will be x equal to a2 e raised to lambda 2 t and y equal to b2 e raised to lambda 2 t, where again a2 and b2 are fixed constants. So the two linearly independent solutions will be this. ഇനി corresponding general solution എന്ന് പറയുന്നത് അതിൻ്റെ linear combination ആയിരിക്കും. So here a1 a2 b1 b2 are definite constants. So the general solution will be of the form x equal to c1 a1 e raised to lambda 1 t plus c2 a2 e raised to lambda 2 t, and y will be given by c1 b1 e raised to lambda 1 t plus c2 into b2 e raised to lambda 2 t. So here c1 and c2 will be arbitrary constants. So this is the form of the general solution when you have two different real roots for the given characteristic equation of the given homogeneous system. So we will see a problem for finding the solution. So where you are having real and distinct roots. So the first question is to solve the homogeneous system. So we have dx by dt equal to 6x minus 3y and dy by dt equal to 2x plus y. So first of all we will assume that x equal to e raised to lambda t and y equal to b e raised to lambda t. They are solutions of the homogeneous system. So assume that x equal to a e raised to lambda t and y equal to b e raised to lambda t. It's a solution. So that implies, so dx by dt will be a lambda e raised to lambda t and dy by dt is b lambda e raised to lambda t. So substituting in the homogeneous system, we get, so you will get a lambda e raised to lambda t will be equal to 6 a e raised to lambda t minus 3b e raised to lambda t, and the second equation is b lambda e raised to lambda t equal to 2 a e raised to lambda t plus b e raised to lambda t. Now e raised to lambda t will cancel off on both sides. So this will give us the equation. So you will get so 6 minus lambda a minus 3b will be equal to 0, and from the second equation you will get 2a plus 1 minus lambda b equal to 0. So this is the system of equations you are getting. Okay, so that is 6 minus lambda a minus 3b equal to 0 varum 2a plus 1 minus lambda. Okay, 2a plus 1 minus lambda b equal to 0. So the system will have a non-trivial solution if the system has non-trivial solution if the determinant is equal to 0. Up 6 minus lambda minus 3 2 1 minus lambda, that must be equal to 0. So when you take the product, you will get 6 minus 7 lambda plus lambda square plus 6 equal to 0. So that is lambda square minus 7 lambda varum plus 12 equal to 0. So the roots will be equal to 3 and 4. So here the roots are real and distinct. So we have got lambda 1 and lambda 2. So lambda 1 is equal to, so let us take lambda 1 equal to 3 and lambda 2 equal to 4. ഇനി നമുക്ക് ഈ ഇക്വേഷൻ്റെ അകത്ത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. വി നീഡ് ടു ഫൈൻഡ് വാല്യൂ ഫോർ എ ആൻഡ് ബി ഓൾസോ. സോ ഓക്കെ, so we are having lambda 1 equal to 3, lambda 2 equal to 4. The equation is 6 minus lambda a equal minus 3b equal to 0. അതുപോലെ 2a plus 1 minus lambda b equal to 0. So when you have lambda equal to or lambda 1 equal to lambda equal to 3 വരുന്ന കേസിൽ, so you will get 3a minus 3b equal to 0, and here you will get 2a minus 2b equal to 0. So that implies a equal to b. So let us take a solution. So I am taking a equal to b equal to 1. That is a solution. ഏതെങ്കിലും ഒരു വാല്യൂ എടുക്കുക, നോൺ ട്രിവിയൽ സൊല്യൂഷൻ ഏതെങ്കിലും ഒരെണ്ണം കണ്ടുപിടിക്കാം. അതുപോലെ when lambda is equal to 4, so you will get 2a minus 3b equal to 0 വരും. രണ്ടാമത്തെ ഇക്വേഷൻ 2a minus 3b equal to 0 വരും. So take a equal to 3 and b equal to 2. So that will satisfy the equation, and so therefore this is a value for a and b. So this I can take as a1 edukam. So a1 b1, and this can be taken as a2 b2. Okay, so that gives us the value. So therefore the two linearly independent solutions are, so the first pair is, so a1 and b1 are equal. അപ്പോൾ e raised to 3t and again e raised to 3t. So this is the first pair of solutions, and the second pair of solution is 3 e raised to 4t and 2 e raised to 4t. Now you can write the general solution. ഇതിൻ്റെ രണ്ടിൻ്റെ ലീനിയർ കോമ്പിനേഷൻ എടുക്കുക. So therefore the general solution is x equal to c1 e raised to 3t plus c2 3 e raised to 4t, and y will be c1 e raised to 3t plus c2 2 e raised to 4t. So that is the required general solution. So here c1 and c2, they are going to be arbitrary constants. So that is the way of finding the roots, the solution when you have roots to be real and distinct. And I want you to do this question as exercise. So find the general solution of dx by dt equal to 5x minus 2y and dy by dt equal to 4x minus y. So kindly solve this question. So we will see the next case in the coming class.